First off, there's this lovely thing called the quadratic formula. It says it will be necessary. You either need to be able to use the quadratic formula and know it, or you need to be able to use your calculator in such a way to get around using the quadratic formula. You should kind of hint that you are using it so that people know that you know what you're doing to solve. But so you may need the quadratic formula, you may not. So this is a really fun problem. That's going to use the ice table and that KC, and it's nice and challenging. So let's go ahead and try. Temperature above 70 degrees Celsius, KCOBr2, gas decomposes into carbon monoxide and bromine. In the lab, you heat a 0.25 mole sample. So that sounds like an initial 0.250 molar sample. The Kc value for the decomposition is, okay, so they give us a Kc equals 0.190. What is the concentration of each species at equilibrium? It sounds like it's going to decompose, so those are going to have initial values of nothing. They gave us a Kc, so I might come up with an equilibrium expression. Products over reactants, they all have coefficients of 1, so there's no powers to the equilibrium expression. And this is where things get fun. So they don't tell us how much things are going to change. They don't give us any final concentration. They might say that this is going to decrease by x. So I might get 0.250 minus x. And then since they have coefficients of 1, if this decreases by x, that has to go up by x. This also has to go up by x. If you're not understanding this at this point, like why this one's negative and those are positive, you really should come talk to me. 0 plus x is x, 0 plus x is x. So hey, we now have one unknown, which is our x, and we can go solve for it. So we're going to go solve for it. So we know Kc, it's 0.190. Br, we're going to put in x. CO, we're going to put in x, and then COBr, put in 2.250 minus x. And now we're going to solve. So I use the quadratic equation. Maybe you get to a form where you can put it into your calculator. So the first thing I might do is I might multiply both sides by 0.250 minus x to get that off the bottom. Zero four seven five minus 0.190x equals x squared. If you don't remember, quadratic formula is ax squared plus bx plus c equals 0. That's where the quadratic formula works for. So I might get into a form like that. I like to deal with a positive a. It doesn't matter though, so I might move these over to the right side. So I got 0 equals x squared plus 0.190 x minus 0.0475. I can plug that into the quadratic formula now. And we can type that all into my calculator, which I did earlier. So A is 1, just so you know, B is 0.190, and C is going to be negative 0.075. It's important to make sure you get that negative sign in where appropriate. And so I'm going to plug it in. So I'm going to take negative 0.190. I'm going to do the plus first. Second square root 0.190 squared minus 4 times 1 times negative 0.0475. Hit enter, and then I might divide by inside the parentheses. Well, it's 1, so divide by 2. And I got an x equal to 0.143 molar. I might use my calculator. I might hit second enter a few times so it goes back up. And where there was the plus sign, I might put the minus sign. Might divide by 2 again. And I get 4 negative 0.3327. Hey, let's see. X needs to be our concentration. I can't be negative, so my X has to be that. And now I forget what my original question was. I did a whole bunch of fun math. Oh, what was the concentration of each species at the beginning? Or each species at equilibrium. So for COBr2, I'm going to put in 0.25 and subtract the positive number, 0.250 minus 0.143, because 0.25 minus x is what will give me COBr2's concentration. Get 0.107 molar. That's one of my answers. And then the other two are easy. They're going to be equal. It's Br2 equals CO, which equals just what X was, which is 0.143 molar. So a lot of math. It's not real hard math. If you use the quadratic formula, that's fine. If you don't know how to use the quadratic formula, but you have a graphing calculator and you can solve using roots or something like that, that's fine.